I want to take the derivative of y equals 7x times e to the x squared. I'm going to call 7x f and e to the x squared g. So when I take the derivative, it's going to be f prime g plus g prime f. The derivative of 7x is 7 times g is e to the x squared plus the derivative of g. Well, the derivative of g is e to the x squared times the derivative of the exponent. So the derivative of the exponent is 2x, and that's the chain rule part, times f. We can go a step further and notice that they both terms have a factor of 7 and e to the x squared. I'm going to pull that out, and I'm going to be left with 1 plus, and then we have 2x times x, will just give us 2x squared. And that's our derivative. F of x is equal to x plus 8 to the fourth times secant of 3x. We'll let x plus 8 to the fourth be f, secant 3x be g. We're going to apply the product rule here since we're multiplying two functions. And whenever we take the derivative of both f and g, we're going to have to use the chain rule. So for x plus 8 to the fourth, we're going to bring down the exponent, keep the inside the same, subtract 1 in the exponent, and then multiply by the derivative of the inside. So the derivative of x plus 8 will just be 1. And then times g, which is secant 3x, plus the derivative of secant 3x. Here we have to do the chain rule. So always start with the outside function. The derivative of secant is secant tangent. You always leave the inside the same. So inside referring to whatever's inside the parentheses. So we're going to have 3x. And then you want to multiply it by the derivative of the inside. So the derivative of 3x is 3. And now we can factor out a secant 3x. Oh, before that, we have to also multiply it by f. Okay, so just to clarify, this part is f prime, this is g, this whole thing is g prime, and then this thing is f. So I just forgot to put the f part there. And notice what they have in common is they have a secant 3x, x plus 8, but here you wanted to look at the smaller exponent. So the question is 3 smaller than 4? And the answer is yes. So we're going to factor out the x plus 8 to the third power. What's left is the 4 in front plus 3 tangent 3x times x plus 8. Since we factor out a cubed, we would just subtract this exponent by 3. And that's the derivative. Y equals 2 to the power 3x plus 1 times natural log 5x minus 11. We're going to label 2 to the power 3x plus 1 as f, ln of 5x minus 11 g. We're going to use the product rule. The derivative of 2 to the 3x plus 1. So for this, let's do it on the side here. The derivative of 2 to the x is itself times ln of 2. So that's the standard one. Now if we introduce 3x plus 1, that means we have to apply the chain rule, since 3x plus 1 is not equal to x. So for every x in this here, we're going to replace it with 3x plus 1, and then we're going to have to multiply by the derivative of that exponent. So that's just going to be 2 to the 3x plus 1 times ln of 2 times the derivative of 3x plus 1, which is 3. Okay, so this whole thing is going to be my f prime. G will just be the natural log of 5x minus 11. Okay, now we want to take the derivative of g. So whenever you take the natural log, the derivative of natural log is 1 over whatever's inside the parentheses times the derivative of the inside. Okay, so that's going to be g prime, and then f will just be 2 to the power 3x plus 1. Next, we look at what we can factor. So from both terms, we see a 2 to 3x plus 1. And we're just going to factor that out. So we'll have 3 times natural log 2 times natural log 5x minus 11. But here we're multiplying the two natural logs. So unfortunately, we cannot say something like this. So this is a little tricky. It may seem like we can combine this, but we're just going to leave it alone. We're going to say 3 natural log 2 times ln of 5x minus 11. And then plus 5 over 5x minus 11. Next, we'll be doing y equals x squared times sine cubed of 5x. X squared will be f. Sine cubed 5x will be g. So f prime g plus g prime f. The derivative of x squared is just 2x times g plus the derivative of g. Okay, this one is definitely a more challenging chain rule problem because we have to apply the chain rule more than once. So let's first think of this. So let's think of sine cubed 5x as like this. If I put it in parentheses, I think that would make it easier. So whenever you're doing the chain rule, you want to think about what is the outside function. So the outside is the cube part. You know, you can think of it like x cubed. Whenever you take the derivative of x cubed, you bring down the power and subtract by 1. So we're going to bring down the power, keep the inside the same, subtract 1 in the exponent. But this is chain rule. Now you have to take the derivative of the inside. So derivative of sine 5x. So this is where we have to apply the chain rule again. So sine is going to be my outside function. 5x is my inside function. Okay, so the derivative of sine is cosine. Keep the inside the same. Multiply by the derivative of the inside. So we can rewrite this. We have 3 and a 5. 3 times 5 is 15. We have sine squared 5x times cosine 5x. And if you really want, you can simplify this further by basically doing a sine 10x, but equals 2 sine 5x cosine 5x. But that should be good enough. Okay, so we'll add that here. And then we're going to multiply it by f, which is x squared. Okay, and then we can factor. So you have a x. Here you have an x squared, but we're only going to pull out an x. Sine 5x, sine 5x. So you always look at the smaller exponent, which will be 2. Okay, so let's pull that out. We have x sine squared 5x. So we have 2 in the first term remaining plus, now we have, actually, we have also the sine 5x. So because we pull out a 2, we have sine cubed, so we need another sine, plus 15. Sine squared is taken care of. We want cosine 5x. And then we also need an x. And that's our derivative.